You see this bridge? Every single cable, every hanger, every deck cross section, it all comes from lines and circles. And those lines and circles are parametric. Change the span, every cable updates. Change the deck radius, every cross section updates. Today, we are building lines and circles in Grasshopper. Day 2. Let's change some components. Day 1 recap super fast. We learned that Grasshopper is a factory. Data flows left to right through components connected by wires. We made a construct point component, connected 3 sliders, and moved a point in 3D space. Today, we connect 2 of those points to make a line. And then we're gonna make circle with a controllable center and radius. These two additions are huge because now we start chaining components. And chaining is how real Grasshopper definition work. You build a chain, step 1 feeds step 2 feeds step 3. And each component does one job and passes its result forward. Let's build it.
Start a fresh canvas or continue from yesterday, totally up to you. Let's place a construct point component. Add 3 sliders for X, Y and Z. Connect them, you've done this before. This is point A. Now I want a second construct point. This will be point B. Same process. Place it, add 3 more sliders, connect them. Set point A to X0, Y0, Z0, the origin. Set point B to X10, Y0, Z0, 10 units to the right. You should see 2 red cross in Rhino viewport, one at the origin, one 10 units to the right. Now, double click the canvas and search for line. You will see multiple results. I want the one with inputs A and B, 2 endpoints. Click to place it. Connect the PT output of point A to A input of line. Connect the PT output of point B, B input of line. Look at Rhino. That's your line. Move points A sliders, the line updates. Move point B sliders, the other end updates. This is a parametric line. Both endpoints are live controls. Look at the data chain we have built. Slider, construct point, line. 3 components, each doing one job. Slider gives the number, construct point converts number to coordinates, line connects 2 coordinates into a segment. This is chaining. A circle needs 2 things. A center, where it is, and the radius, how big it is. Simple enough. Let's start with the radius. Place a number slider, name it radius, range 1 to 20. Now place a circle component. Double click canvas, search circle. You see the circle has 2 inputs, P and R. R is easy. Connect your radius slider to R. But P is interesting. P stands for plane and this is an important concept. Let me explain.
What is a plane? Imagine a sheet of paper floating in a 3D space. It's flat, it has a center point, the origin of the plane, and it is known which direction is up related to itself. A circle needs a plane to know where should I be drawn and which way should I face. If you just give a circle a point, it doesn't know which way to face. Should it lie flat, stand vertically or face diagonally? The plane tells it. Here is my origin and here is my orientation. The XY plane is the default flat plane. It lies flat on the XY floor facing upward. For most 2D circles, that's what we want.
So here's the process to put a circle at a specific point. First, place a construct point with 3 sliders for the center position. Set it to X5, Y5, Z0. Now, place a XY plane component. Double click canvas, search XY plane. Connect the PT output of construct point to O input of XY plane. Connect the plane output of XY plane to P input of circle. Rhino now shows the circle. Its center is at 550 and its radius is whatever your slider says. Now move the center point sliders. The circle follows. The chain is sliders, construct point, XY plane, circle. And drag the radius slider, the circle grows and shrinks. You now have a fully parametric circle. Controllable center, controllable radius, all connected in a chain. Practice exercise. Step 1. Set your line endpoints to make a vertical line. Point A at 500, point B at 5010. The line should be vertical, 10 units tall, position 5 units from the origin. Step 2. Set the circle center to 500, the same X position as your line. Step 3. Set the radius to 3. Now, here's the cool part of the challenge. Can you make the circle center automatically follow point A of the line? Connect the PT output of point A directly to the O input of the XY plane that feeds your circle. Remove the separate center sliders. Now, when point A moves, the circle follows. This is called chaining, a dependent relationship. One component's output automatically becomes another component's input. This is the real power.
Day 2, done. You built a parametric line, you built a parametric circle, and you learned that chaining components where one feeds the next is how the complex Grasshopper system works. Tomorrow is day 3, vectors. Vectors are arrows that gives direction and distance. You use them to move geometry precisely, and you see the move component for the first time. Subscribe and I'll see you tomorrow. Drop your challenge result in the comments. Did you change the circle to follow the line endpoint? What happened when you moved point A? See you in the next one.